Hey, this is Isa with Journey to Programming. Today what I'm going to do is I'm going to begin the tutorial series for Computer Science Basics, and what we're going to begin talking about is data structures. Specifically, in this tutorial we're going to talk about arrays. So, as many of you guys probably already know, arrays are pretty well used in almost all high-level languages and low-level languages too. And what an array actually is it's a linear structure. So what do I mean by it being a linear structure? Well, it is a structure that holds elements in a sequence. So that makes it a linear structure. And generally what an array is it's a data structure that contains either values or objects. So that is pretty much the definition of an array. Usually all elements are indexable. And let's go ahead and state that they always are indexable, so it's not usual, they always are. And in almost all high-level languages right now, you're looking at arrays being zero indexed. What I mean by them being zero indexed is, imagine we declare an array with 10 elements. The indices for that array will begin at 0, and the last element will be indice 9. So your actual indexes, if you were to try to access the arrays via index, would be 0 through 9, rather than 1 through 10. That is the case in almost all high-level languages. There were a few cases where I've worked with languages that actually began with a 1 as their base index, but in almost all high-level languages, especially the C languages, it is 0 indexed, Java 0 indexed. So for most cases, you're good with that information. The next few things that you should know about arrays is arrays are fixed in size. So as many of you guys know, if you guys wanted to declare an array and you decide at a later time you want to add to that array and you've already maxed it out, there is no real cookie cutter way to do that. There's no simple way to do it. It is always costly because what you have to do is you have to allocate a new array and copy all the elements from the old array to that new one. And that is a fairly slow process. Of course, nowadays with the technology we have, it's probably not going to be noticeable, but if you're doing it a lot, it's not a recommended thing to do. You'd end up wanting to use a different data structure, maybe a list, or something that's resizable in that case. The next thing to think about is, how is memory organized when you're using an array? So arrays are great because they're indexable, and the way they're indexable is in memory. When you create an array, the elements are actually right next to each other. So that's basically saying that an array is stored in memory contiguously. So all of the elements are right next to one another. The way that works is the first index of your array is basically your foundational index. It's the first address, and every other element after that will exist right behind it. So as long as you always have access to that array as first index or the first address, you'll always have the rest of the memory following behind it. If you work with pointers in C++, that is a great way to kind of track down how the memory is stored. If you decide to breakpoint in your code and go and look at your actual memory registers in Visual Studio, then you can actually take a look at how memory is stored as well. And if you have an array declared, you can actually see your values or your objects in contiguous space. So, what are some benefits to arrays? Well, some great benefits to arrays are speed. So random access with an array, because it's indexable, is big O of 1. If you're confused by what I mean by speed or big O of 1, I'm talking about time complexities. So arrays are fast structures when you want to retrieve a specifically known element quickly. And what we'll do is we'll end up comparing data structures as we go on in the series, but just keep that in mind. Arrays are relatively fast because they're indexed. When I want an element and I know where it's indexed, all I have to do is call that array square brackets, and that gives me, and pass in the index, and that gives me the value or the object in that index of the array. And that makes it quite fast in comparison to some other structures like a linked list. But we'll talk about that more when we touch on linked lists in the next lecture, in the next tutorial of this series. For now, that's enough of me just talking. Let's jump into doing a little bit of array manipulation. So, jumping into an empty C# project in Visual Studio, I'm just going to go ahead and create a very simple array here, and I'm going to make an array of integers. What I'm going to use this for is an example of keeping track of weekly temperatures in the area. I live currently in Southern California, so I'm going to make up some rough temperatures to fit into this array. But the first thing I'm going to do is I'm going to declare an array of ints. So I'll go ahead and say int, square brackets for an array, and I'm going to call it weekly temp is equal to a new int array, int array of size 7. So that is one way for you to declare an array of 7 elements. Instead of declaring an empty array of 7 elements or 7 ints, what I'm going to do is I'm actually going to declare them in this declaration. So what I'm going to do is I'm going to pass in 7 ints, and I'm just going to make these temperatures up off the top of my head. So let's say Southern California currently in September. I'm going to estimate that, let's say Sunday was 85, say 83 on Monday, 83, 81, 78, 84, and then let's say Saturday was 88, because it's September in SoCal and the temperature always ends up in being too hot for me, but this works. So we have 7 temperatures. I'm going to comment saying the first index is Sunday and last is Saturday. So the way this index or this array is kind of representing is Sunday through Saturday of the week. Okay. So with this, we've declared an actual array. If I wanted to print this array, or if I wanted to actually see what all these values are, print them into the log, what I would want to do is I'd want to loop through it. So in an effort to give you guys some examples of how to do some basic manipulation, I'm going to show you guys how to loop through the array going forwards and then going backwards. So the first thing I'm going to do is I'm going to do a for loop, and I'm going to say int I equals 0, because remember, arrays are 0 indexed in C# on all the C languages and almost all high-level languages. And what I'm going to say is while I is less than our array dot length I++. So what we actually did in this for loop here is we declared a variable as 0. We're defining a condition. We're going to keep on looping through this for loop until our variable exceeds the size of our array, and the increment we're going to take on each loop is going to be our variable plus 1, because I++. This also could have been written as I is equal to I plus 1. But I++ is a simplified way of writing it. Okay. Now, in order to access each one of our indexes, all we have to do is say our weekly temp, which is our array name, square bracket I. Now, this doesn't really do much for us because this is accesses the information. What I actually want to do is I want to print out to the log. And the way I'm going to do that is I'm going to do a console.writeLine. And what I'm going to do is I'm just going to give you guys some basic information here. So I'm going to say index and then I'm going to print out the index number, and then I'm also going to print out the value that is at the index. And I'm doing a little bit of formatting here, so I'll explain this in just a minute. So what I'm actually doing in this write line is I'm saying on each iteration of this loop, print out the index number and then print out the value associated with that index. What you see here with these curly brackets and a number is a way to add in a parameter to this print statement. And the 0 stands for the very first parameter that we're adding into this write line call. This stands for the next one, so the second. And if we run this right now, which I'm going to, we're going to get a printout to a command console. But what I'm going to do is I'm going to breakpoint our application right after the print so that the console stays open. So on the first iteration of this loop, what we're seeing is index 0 has a value of 85. Comparing to our array, that is true. So index 0, which is our first index of our array, has a value of 85. If we look at our I value by hovering over the actual variable I at the end of the first iteration of this loop, we can see that it's currently 0. And we know that weekly temp at 0 is equal to 85. Now if I go ahead and press continue and we look at I now, we've seen that I is incremented to the next value. So now if we look at our command console or our console app, you'll see that index 1 is equal to 83, which is right. So if we compare that to our array, our temperature was 83 on Monday, which is the second value in the array. And what I'm going to do now, so we don't kind of step through this slowly, I'm going to remove that breakpoint from the end of the loop. I'm going to put it before the end of our main, and I'm just going to continue. That's going to allow us to print out the entire array and finish that for loop. And now you're going to see the comparison. So index 0, 85, 1, 83, 2, 83, 3, 81. All those numbers look right. So we just looped from the beginning to the end of the array using this for loop. So there's a good example of how to loop through an array from the beginning to the end. Let me show you how to do it in reverse order now. So the way to write a for loop to do this in reverse is pretty simple as well. So if we write one in reverse, we could say int j, in this case, is equal to the actual length of our array. That way we're beginning at the last index. Because we know our weekly temperature array has 7 variables, we know that this length is technically going to be 7. But in an array, once again, indexes begin at 0 and end 1 less than the actual length. So it's actually going to be, in this case, 0 through 6. So what we're going to do is we're going to declare j to be equal to the length, which is 7, minus 1, which is 6, which stands for the last index of this array. Okay, what we're going to do is we're going to let the array loop as long as j is greater than or equal to 0. Lastly, we're going to say j minus minus on each loop. So let me explain again what's going on here. We're defining j to be equal to the last index of our array. That's what's going on in the first parameter. The second is the conditional, which is saying we're going to loop as long as j is greater than or equal to 0. So j is going to begin at 6. Each time it's going to decrease by 1, which we're stating at this incremental step here. It's going to go 6, 5, 4, 3, 2, 1, 0. Now when it hits 0, we want it to run one last time because the very first index of the array is 0 indexed. After it runs that last time at 0, j will become -1, J will compare to this conditional. It is no longer greater than or equal to 0 because J is equal to -1 at that point, and it will stop running this loop. So let's go ahead and print out this statement, or this for loop here. Let's change, because I just copy and pasted the print statement from the previous for loop. So let's change the variable name to J, and let's go ahead and run it with our breakpoint where it is. So now if you pull over that console window, what you're going to see here is 14 print statements, but the first 7 are related to that first loop. The second 7 are related to the reverse order printing. So what you see is that we actually began at index 6, which is our last value or object in this array, and we printed out the array backwards. So what I've shown you guys there is just 2 simple manipulations of an array, how to loop from the beginning to the end and how to loop backwards from the end to the beginning. Another way to use arrays is, for example, in this case we have a array of weekly temperatures. What if we wanted to know the average temperature for that week? Well, this is just an additional method we could end up writing just for, let's say, extra credit or an extra bonus of tutorial. What I'm going to do is I'm going to show you guys how to take an array, calculate the average of the ints, and return the average number. So what I'm going to do is I'm going to create a new method. I'm going to make it a private int average, and I'm going to give it, let's call it get average. I'm going to pass in an int array, and I'll call it values. So what I've created is a helper method here called get the average, or get average. It wants a parameter which is an int array, because if we're gonna calculate the average of a array, it's likely that they're going to be values of int, float, or one of the other primitive types which can be calculated. So once we've passed in that array, what I can actually do is I can loop through it just like I did it before by using a for loop, and I could say, well, int I is equal to 0. I'm not going to read this out loud. I hope you guys remember it, but I'm just going to write it out. So while I is less than once we've written that array, what we want to do is we want to calculate the average or the total of all values currently. So what I'm going to do is I'm going to create a int total sum. I'm going to declare it's equal to 0 at first, and I'm going to add the value in each array index in this loop. So what we have here is every time the loop iterates, we're going to add the value at that index into our total sum. At the end, before we finish up this method, what we need to do is calculate the average. So the way you calculate the average is you take the total sum and divide it by the amount of values that existed in the sequence or in the array. So what we can do is we can say values.length. And remember to say total sum is equal to total sum divided by that, because this is a calculation that will return an int. Lastly, what we want to do is we want to return total sum. Oh, we want to return average actually. So let me clarify here. So int average is equal to total sum divided by values.length. One mistake, which I hope you guys caught here, is we're calculating an average and storing it in an int value. What if that average ends up being a decimal? Well, that would end up being rounded, and we probably don't want to round when we calculate an average to an int. At least In this case, I'm going to say that we don't. So what I'm going to do is I'm actually going to change our method here so that it returns a float. And I'm going to say that our average is actually going to be calculated as a float. So what I'll end up doing is I'll cast right before doing the calculation just to make sure, although most of the time it's not necessary anymore. So what we could end up doing is make that a float, cast each variable to a float before doing the calculation. Yay! And then what we're going to do is we're going to return that float average. So let's go ahead and check this out. Let's say console.writeLine. Let's say average weekly temperature. And then I'm going to do a parameter so we can actually call this function and format our printout statement nicely. And I'm going to say get average okay, and I'm going to pass in weekly temp. Now we're getting an error here. That's likely because we do not have a static function and we have not created an instance of class program. So what I'm actually going to do is I'm just going to make this static, which is perfectly fine for this case. And now we can call get average weekly temp. Let's go ahead and run that. Now if you actually look at your console print line there, what you're going to see is the actual average temperature calculated based on the past 7 days, or the fake array of 7 days we allocated to that array. So that just about wraps up a very introductory level sequence on how we manipulate an array, how we loop through it front to back, and then how to loop through it in reverse order. I also added in an example of utilization of an array, a method that calculates the average of the sum of that array using a loop that I just showed you how to write. Now, if you end up having any questions or if you end up practicing this and you're confused about how we did something, please feel free to write a comment or send me an email. Our contact form is on journeytoprogramming.com, and then you can also comment at the bottom of this post. I hope this helped. Stay tuned to the next tutorial about linked lists.